I'm Anil Kumar. Welcome to my series on solving word problems relating linear systems. When we say linear systems, we mean more than one equation. So we'll be dealing with more than one equation. In this case, more than one linear equation. I'm going to take up problems related to geometry, money, mixture, interest, and distance, speed, time. Now, these are very important questions. I would like you to pause the video for each question, understand the logic. Once you understand the logic, you can solve any question on that particular topic. So, when we talk about geometry, we'll just take some shapes. Basically, we'll begin with rectangle and we'll see how length and width are related from the word problem. The two variables will be length and width. Relating these two variables, we can solve the equation by either substitution or by elimination. Now, these are the methods which will be used for solving any linear system as such. Correct? We'll also concentrate on illustrations while we solve. For example, when we talk about mixture, we say we have two things here. These two things are being mixed. So we'll make a sketch which will look something like this. These two things are being mixed to get the third thing. Now that will help us to make equations. And all the equations which will be made will be in product form. That is to say, avoid fractions. Right? So if we have a situation which is kind of interest, we could have something here. Now, that amount in dollars could be invested in two or more areas. So we'll make a sketch which will be kind of like this. So once we make a sketch, it'll be very clear how to solve these questions. So that will be a general sketch for a problem which involves mixture. And this will involve, let's say, money or interest. Coming back to distance, speed, and time. Distance, speed, and time problems will be solved using the relation that distance is speed into time, right? So that is the product form. And we'll actually make a table in this case, which will have three different columns relating to distance, speed, and time, and different conditions, correct? So that kind of matrix will help us solve distance, speed, time questions. So we could have this for distance, speed, and time, and knowing the values in between relating with this formula, distance equals to speed into time, will be able to solve most equations. Now let's take the questions one by one and see how these strategies can be applied and any word problem based on linear system can be solved. The very first example here is a swimming pool has perimeter of 96 meters. So let's make a rectangle. We are assuming this swimming pool to be rectangular. In fact, I should have written here a A rectangular swimming pool has perimeter of 96. That means we are given sum of length and width. So perimeter is 96, which is equal to 2 times length plus width. That is the equation which relates the two. And the variables defined are, let L be the length and W be the width. So we can define the variables first and get the equation. Now, second statement here is, the length is 3 more than twice the width. That means length is means equal to 3 more than twice. So that means we'll do 2 times width plus 3. That means 3 more than twice the width. Do you see that? So we get two equations. We'll number the equations as 1 and 2. And now we can solve this question with elimination or substitution. Correct? Find the length and width of the pool. That is what we need to do. So we know what length is in terms of width. So in this case, substitution is a good method. So let's substitute equation 2 in equation 1. Right? So that is to say, 96 will now be equal to 2 times. Instead of length, I will write 2W plus 3. We already have 1W there. Do you get an idea? Now to solve, we can divide this 96 by 2. 96 by 2. And what we get here is 3W plus 3. Correct? 96, half of 96 is 48. Now this is a simple equation which can be solved. So we get 3W equals to 48 minus 3, which is 45. And that gives you the value of width. So width will be equals to 45 divided by 3. Right? And that is 15. So once you get width as 15, you have to include the units which are in meters. And now length could be found from equation 2, which is 2 times width of 15 plus 3. Substitute 15 there, we get 30 plus 3, which is 33 units of meters. And so we get our answer, that is length is equals to 33 meters and width is equal to 15 meters. So I hope the concept is absolutely clear. A simple sketch. Define variables. That is how we define variables. We'll say let L be length and W be width. And then you begin writing equations and solve them by substitution or elimination. Since here length was given directly as twice width plus 3, we adopted substitution. Right? Next example here is, Sai invested $3,000 in two funds. One paid interest of 7% per year and the other paid interest of 5% per year. So we have a big amount here. This amount is being invested in two different plans. So that is how you can represent this information. Now the amount given here is 3,000. Let the amount invested at 7% be, let us say, X, and at 5% be Y. Since the amount is 3,000, we know 3,000 should be equal to X plus Y. So that is how you get your first equation. Now the statement here is, at the end of second year, he earned total interest of 380. So what we are given here is that at the end of second year, so after 2 years, $380. So we could actually simplify this condition and say yearly interest. We are taking simple interest, right? Will be half of this. So 380 divided by 2, which is in our case 190. And all units are in dollars. We'll only put units in the answer. Now, if you look individually, if X is invested at 7%, then what is the interest? Then the interest in this case will be 0.07 times X, product form, right? 0.05 Y, that is the interest. So let's write down the interest equation. So this interest of $190 should be equal to sum of these two, which is 0.07X plus 0.05Y. So we get two equations, correct? Now, we need to solve these equations. We could do elimination or substitution. So let's number these equations as equation 1 and equation 2. To solve by substitution or elimination, what we can do is that we can just multiply the first equation by, let's say, 0.05. So if I times first equation by 0.05, what do I get? You can use the calculator, right? 3000 times 0.05. So it's 150. So you get from the first equation, you get 150 equals to, we are multiplying by 0.05 X plus 0.05 Y. So we get our third equation. There is no need to make these numbers as whole numbers. You are using calculator as such, so decimals is okay. Now you can see that if you compare equation 2 and 3, we could eliminate Y by subtracting one equation from the other. So let's do equation 2 minus equation 3. So that will eliminate. So 190 minus 150 gives you 40 here, equals to. Now here you get 0.02x and that becomes 0, correct? And simply dividing by 0.02, we get the value of x. You could also think like this if you don't want to use calculator, which may not be allowed at times. 40 and 2 zeros, do you see that? Divided by 2, which gives you a value of 2000. So x is 2000, what should y be? We can write here, y will be equals to 3000 minus 2000, which is 1000. Correct? So the amount x, which we just found, is $2,000. So $2,000 is invested at 7% interest, and $1,000 is interested at 5% interest. Do you see how beautifully the diagram illustrates? You can write down your answer separately. The investment is $2,000 at 7% and $1,000 at 5%. Does make sense? So if you solve like this, you easily get solution of all such questions. Perfect. Now let's move on and take other kinds of questions. Here is the next question. You can always take a break in between and then begin. The question here is, students hold a car wash to raise money for a school trip. They charge $7 per car and $10 per van. If they washed a total of 52 cars and vans and earn $457, how many cars did they wash? Right? So first step always is to define variables. Let the number of cars be C and number of vans be V. Right. So we have this variables. As you read, you can write down the equations. Since we are given total of 52 cars, that means C plus V is equals to 52. So normally you will get one equation relating to numbers. The other is dollar value, right? Total dollar value is, so first equation, let me write here, equation 1 is about numbers. And now we are going to write equation 2, which will give dollar value. $7 for each car, so we can say 7C, plus $10 for each van, and total number of dollars is 457. That is the money part. And we have written the equation in product form, correct? So that is how you easily get your equations. You need to find how many cars did they wash. You want to find what C is, okay? So we can eliminate V. So to eliminate V, I will times our first equation by 10. So if I do that, I get 10C plus 10V equals to 520. So we get our equation number 3. Now it's a simple step. We have to do equation 3 minus 2 to get what C is, right? So now we will do equation 3 minus equation 2 by elimination. So 10 minus 7 is 3. We get 3C equals to we cancel 520 minus 457. Okay? So that's what we get. So from 10, if you take away 7, we get 3. And from 11, if you take away 15, you get 6. 63. So C is equals to 63 divided by 3, which is 21. So we get the number of cars as 21. So our answer is number of cars washed is 21. Do you see that? So if you need to find number of vans, it will be 52 minus 21. Okay? 31. So that's how you could do it. Next question here is, a total of 27 coins in nickels and dimes make $2.15. How many of each type of coin are there? So again, start with let statement. Let the number of nickels be n, number of dimes be d. It's good to have valuable variables. You could just relate to them, right? And says total of 27. So when we say total, that is, we're talking about numbers. So we get our first equation, which is nickels plus dimes number is 27. We'll call this as our equation number 1. And second is the dollar value. Total dollar value is $2.15. Nickel is how much? Nickel is 5 cents, correct? So we get 0.05 times nickels plus dimes is 10 cents. And total amount should be 2.15. We get a second equation. Got it? Now, we could just multiply the first equation by 0.1. So we'll times equation 1 times 0.0, okay. Since I wrote 0.5, we'll times it with 0.10. That is simpler, right? Okay. So we get equation as 0.10 nickels plus 0.10 dimes equals to 2.70. Is that okay? So that is simpler. So we'll do that. And now it's question of taking away the difference between equation 3 and equation 2. So if you do this minus this, what do you get? You get in nickels 0.10 minus 0.05 gives 0.05 nickels is equals to 2.7, take away 2.15, right? So when you subtract, you get 5 here, 10 take away 5. 6 take away 1 is 5, 0.55, correct? And from here, you can find the amount of nickels. So let me rewrite this equation. We have 0.05 nickels is equals to 0.55, or the nickels is 0.55 divided by 0.05. It is as good as dividing 55 by 5, right? So that gives you 11. So we get 11 nickels. So once you know nickels, we can find how many dimes. So dimes is 27 minus the nickels, which is 27 minus 11, and that gives you 16 dimes. So our answer is that there are 11 nickels and 16 dimes. Is that clear? So that is how you could easily solve question related to money. Now here is a mixture problem, very important. I need 500 liters of a 34% acid solution. A lab has 25% and 50% acid solutions available to make. So basically, we are mixing two things. So I prefer to make this diagram in a way where I could illustrate what is being done, right? So these two things are being mixed together to get what I need. Correct? We are given concentration of what we need and how much we need, 500 liters. So this is 500 liters and 34%. This is what we need. We begin with 25% and 50%. We don't know how much of each. That is what we need to find. Is it okay? So let it be X and Y. Clear? So as soon as we write this, we get our equation. So the first equation is we have X plus Y equals to the total amount of 500 liters. And second is about the concentration, right? So this is 0.25x, that is 0.50y, and this total here is 0.34 times 500. That is the equation which relates with concentration, right? So here what you get is 0.25x plus 0.5y equals to 0.34 times 500. So you get both your equations. Let's number them as our equation 1 and equation 2. So once we have two equations and two variables, we can solve using substitution or elimination. Perfect. What do you prefer? You could use any method. I prefer to use elimination here. So what we will do here is we'll multiply the first equation by 0.5. So I always take the bigger number, right? 0.25, I did 0.5, right? So if I do that, then the first equation becomes 0.5x plus 0.5y equals to 0.5 times 500. Do you see that? So this could be written as 0.5x plus 0.5y equals to, when I multiply by 0.5, one decimal moves, so I get 250, 5 times 5. And here I have second equation. So let's call this as our equation number 3. I am rewriting equation 2. We have 0.25x plus 0.5y equals to, now we have to multiply this 34 by 5, right? Two decimals can be moved out to get 34. 5 times 4 is 20. 5 times 3 is 15, and 2 17. We get 170, correct? Now is the question of subtracting one from the other. So we are doing 3 minus 2. In that case, what do we get? We get 0.25x, this cancels, is equal to, take away 0, 15 take away 7 gives us 8. And so x is equals to 80 divided by 1/4. Correct? 80 divided by quarter. This is 1/4 of this, which gives you the value of x, right? So you can use calculator. We have 80 divided by 0.25. That gives you 320, right? So you get the value of x. Without calculator, 0.25 dividing by 0.25 is as good as multiplied by 4, or dividing by quarter, 1 over 4, right? So times 4. Since we know what x is, we can find what y is. Y is 500 minus 320. Perfect. And that gives you 180. And the units are in liters. So we get our answer that the mixture should be, so x is 25%, so 320 liters of 25% solution plus 180 liters of 50% solution, or you can say acid, right, is required to get the result. Is that clear? So I hope this illustrates very nicely how we can solve any question related to mixture. Now let's take the last example, which is based on distance, speed and time, and there you will also learn how to avoid fractions to solve problems. I hope that helps. The question here is, Anil drove 255 kilometers from Toronto to Algonquin National Park in 3.75 hours. He drove part of the way at 100 kilometers per hour and the rest at 60 kilometers per hour. Find the distance he drove at each speed. Now, these kinds of questions, which are related to distance, speed and time, we should know the relation between distance, speed and time, which can be remembered with the help of a triangle, right? So we know distance d is speed into time. So that is the relation. Second part, to solve such a question, I prefer to make a table. Now here is a small table which will always help you to solve any question related to distance, speed and time. So we'll actually translate the information. We say distance, and distance is in kilometers in this question. Speed will be in kilometers per hour. Time is in hours. Now we are given two different conditions here. One is the speed of 100 kilometers per hour. The other one is 60 kilometers per hour. Correct? So these are the two conditions. So we can write here that it is part generally in these two. So we are given speed. Let me write down the values in the table. So we are given 100 kilometers per hour as one speed. The other one is 60 kilometers per hour. And what else are we given? We are actually given total distance and total time. So let me call this column as total. So here we are given total distance of 255 and total time of 3 hours. I should write 3.75 hours, right? 3/3/4. That is to say 3/3/4. Do you understand? So 15 minutes less than the 4th hour. That's what it means. Okay. Now the idea here is that how to choose my variables. If I choose variables x and y for distance, in that case I get time as distance divided by speed. You get the idea, right? So what I do here is I choose a variable x and y for time, not for distance. Do you see the trick involved? So the key here is to use the variable here for time. In that case, I know that the distance will be how much? Product of speed and time is distance. So we get this distance as 100x and the other distance is 60 times y. Do you see that? So now we get different equations to work with. one set of equation is right here, which tells you that total time is x plus y. So we could write one equation as x plus y equals to 3.75. And the second equation which you get is right here, which is 100x plus 60y equals to 255. Do you see that part? Both these equations do not involve fraction. So that is what we have done in doing so. Avoid fractions. Did you see that? No fractions. At times, if you define x and y as distances, then you'll get time in fractions and you'll be working with numbers which are difficult to work with. So we have got two equations. Let me call them as equation 1 and equation 2. To solve, what should we do? Simple. Let's multiply the first equation by 100. So what we get here is 100x plus 100y is equals to 375. And we get this equation as our equation number 3. Now, to solve, we can just take away one from the other. So we'll do equation 3, take away equation 2, and what do we get? 100x cancel, and here we get 40y equals to 375 minus 255, which is equal to 5 take away 5 is 0, 7 take away 2, 5 is 2, and 3 minus 2 is just 1. And so we get y equals to 120 divided by 40, which is 3. So we get time 3 hours for y. Do you get the idea, right? So if y is 3 hours, what is x? X will be equals to 3.75 take away 3, right? Since x plus y is 3.75, that is 0.75 or 3/4 of an hour, correct? Once we know these times, which we just calculated, so we found y equals to 3 and x we found as 3/4, right? 0.75, 3/4. We can now find the distances. Do you get it? So now, since we want to find the distances at each speed, so distance at 100 kilometers per hour is how much? X times 100, which is 0.75 times 100 or 75 kilometers, right? And distance at 60 kilometers per hour is how much? Is time taken, y is 3, right? So it is 60 times 3, which is 180 kilometers. Do you see that? And now you can also check your result by adding them. So if you add 5 plus 0 is 5, 7 plus 8 is 15, and 1 plus 1 is 255 kilometers. Do you see that part? So we get our answer, and that is distance traveled at 100 kilometers per hour is 75 kilometers, right? And that at 60 kilometers per hour is 180 kilometers. So that is a neat solution to such a question. So I'd like you to pause the video, try to understand how we totally avoided fractions to solve our equation, which could be difficult, right? So what did we avoid? We avoid fractions. You know, if you define distance as x and y, you may land up with equations with fractions, which we avoided, right? So write equation for distance. So what you have done is define time time and avoid fractions. So that is my suggestion to solve such questions. I hope the concept is absolutely clear. Feel free to write your comments and share your views. You can also solve this equation by taking x and y as distances, right? Then you will see what I'm trying to say. I hope that makes sense. Feel free to write your comments and share your views. And if you really like and subscribe to my videos, that'd be great. Share my videos with your friends. Thank you and all the best.